Welcome, ladies and gentlemen, to Integrated 2 Math. In today's episode, we will be continuing our journey with quadratic inequalities. We will be doing a bunch of examples here. And so the way this works is I'm going to go ahead and factor them. Now again, before I even initiate the problem, I should read it. I should say x squared minus 3x minus 18. And in my head, I'm kind of already thinking, all right, I got a parabola here that's upward facing, an upward facing parabola, and I want to know where he's greater than 0. Which means I want the parabola to be above 0. So what I'm looking for, this is what I'm looking for. I'm looking for all final intervals that are positive. So again, that's my battle plan for this problem here. So let's go and just do it. So the factoring part's easy. It's x minus 6 times x plus 3. I get x equaling 6 and negative 3 here in my sign chart. What I get is I get negative 3 and 6. And again, I'll just go and partition them down. And again, you should start noticing a pattern with how these things go. I'll go and plug in numbers this time, and I'll probably never do it again. I'll show you guys the shortcut with example 2 here. So a number that's smaller than negative 3 is going to be like negative 5. So negative 5 into both of these guys will be negative. In between negative 3 and 6 is like 0, so that's going to be minus plus. And then beyond 6 is like, I don't know, 12, so plus plus. Meaning, again, with all of our inequalities, the terms are all being multiplied. So I got a plus here, a minus here, and a plus here. And which one do I circle? Well, it all depends on the original problem, right? The original problem wanted me to find out where this quadratic was above 0. Above. The positive is what I'm looking for. So I'm going to circle my positive ones. And I'll go ahead and say, all right, well, that's going to be true if x is less than or to the left, right? To the left. That's what this arrow is for, to the left of the negative 3, or as long as x is to the right, notice the arrow, x is to the right of the 6, and that is the answer for this problem. So pretty fast with these quadratic inequalities, as long as you kind of know what you're doing, they end up, kind of getting a tempo. Before I move on to the next example, I do want to show you guys this in the graph. I always like to reinforce this thing with the graph, so I will go ahead and delete all of this nonsense right here. So I'll go and put in these functions here. So x squared, let's see, minus 3x minus 18. So there is my parabola right there, and I will go ahead and graph the 0 here. And again, I don't have to graph the 0, but I will just because I feel like it. So again, when is my blue going to be above the red? That was what the question was asking, right? Parabola above 0. So from here, let's go and find the points of intersection. I think we already know them. Lower bound, upper bound, hey, negative 3, 0. We had that as part of our answer. Intersection again. 6, 0. We had that as part of our answer, right? Negative 3 or 6. So again, going back to the graph. When is the blue above the red? Well, the blue is above the red anywhere to the left of this dot right here. Even though it's pretty steep, this point way up here is to the left of this dot. So if x was less than negative 3, which is exactly what we have here, and as long as x is to the right of the 6, which is what we have here. So again, just reinforcing the whole graphing idea, just so that you guys can have this in your back pocket here. Alright, so that is actually the slow way to do these sign chart problems. I am going to introduce you guys to the fast way, starting with this example. So here comes example 2. I'm going to go and throw down, x squared plus x minus 6, and I'll go ahead and say less than 0, or less than or equal to 0. So again, in my mind, I'm already thinking parabola below 0, which I'm thinking already is negative. Okay, that I'm thinking look for the negative signs in my final interval. So in my factor, it's going to be looking like x plus 3 times x minus 2. So my critical numbers are going to be x equals negative 3 and positive 2. That's what gets put into the sign chart. Whoops, that line is way not straight. Not like that one's much better, but that's okay. Negative 3 and a 2 here. Alright, so let me show you how I can do this pretty fast. So x plus 3 and x minus 2 here. Well, what I do is I acknowledge what types of functions these are individually. X plus 3 and x minus 2, these are all lines. They're both lines. They look like that. This guy looks like this. Now, they're upward facing, which means they're never going to be turning around. They're linear, they're upward facing, which means they're going to be going from bottom to top. But they're linear, which means they're never going to turn around. So from here, what I'm going to do is I'm going to look at this function here, x plus 3. And I'm going to ask myself, what number makes this guy 0? What number makes him 0? Well, it's negative 3, right? Notice how negative 3 is on the sign chart. So that means that anything to the left of the negative 3 for this upward-facing line will be negative. And anything to the right, on the right side, greater than negative 3 for this function only, will be positive. Using that same logic for x minus 2, anything to the left, the number that makes this guy 0 is 2. 2 is right here on the sign chart. The numbers that make them 0 will always be on the sign chart. Because this is a upward-facing line, the 2, anything to the left of the 2 will be a negative value, and anything to the right of the 2 will be a positive value for this function and this function only. So that can help you move a little bit fast, especially in the later examples of this video. Plus, minus, plus, no surprise there. Below, which means I'm looking for the negative value, which means x has to be in between negative 3 and 2. Notice how I had to include the equal sign because the original included the equal sign. Okay, so let's go ahead and do another example of this because it starts getting a little dicey when you get into coefficients that are not 1. So if I give to you something like this, so 2x squared minus 5x, and I'm going to say greater than 3. So pay special attention to this example. There are a couple of snags about it. One is that you don't have a coefficient of 1 anymore. 2, this thing is not equal to 0. I've got to set this thing equal to 0 because a sign chart is only valid for things that are set equal to 0 because whether something's positive or negative can't be determined by the number 3, right? Something can be below 3 and be positive. Something can be above 3 and still be positive. So you see there's an ambiguity with the sign chart if this thing's equal to 3. So I will not set him equal to 3. I'm going to set him equal to 0. So what I've got is I've got 2x squared minus 5x minus 3 is greater than 0 now. Once I have him equal to 0, now I can do a sign chart on this thing. I will factor him, but before I do that, I forgot to ask my essential question. My essential question is, what is my final interval that I'm going to be looking for? Well, the parabola here has to be greater than 0, which means I'm looking for something positive. So how does this guy factor? 2x, x, I'm guessing a 3 here and a 1 here, minus, plus. So from here, x equals 1/2, or rather negative 1/2, and x equals 3. These are my critical numbers that now go into the sign chart. So I'll go ahead and put the sign chart, actually I'll put them right here because I'm running out of space below. So negative 1/2 and 3, and it's really good because when you, the shortcut that I just showed you in the last example is really good for problems like this because when you have fractions, things can get a little bit dodgy, especially if you have two fractions that are really close to each other. So when it comes to x minus 3, I'll go into him first. What number makes him 0? The 3 makes x minus 3 0. I'll go ahead and go minus, minus, plus, because anything to the left of the 3 for this guy will be negative, and anything to the right of the 3 will be positive. The number that makes this guy 0 is negative 1/2. He's an upward-facing line. He'll go minus to the left of the 1/2, or the negative 1/2, and he'll be plus on the right side. The final intervals will be plus, minus, plus. How do I know which ones I'm going to circle? I look back at the original problem. I'm greater than 0. I'm looking for my positives. Positive, positive. So x has to be less than or equal to negative 1/2, or x has to be greater than or equal to 3. Box it up. Whoops, but don't cross off your answer. Box it up and get ready to move on to the next problem. I'll be back in a flash after I clean up the board. We are on example number 4 here, and it's very similar to the last one. There's a couple of things that I just want to make sure we are very much aware of. Again, whenever solving a quadratic inequality, please, under all circumstances, set him equal to 0, because that's how you're going to employ your sign chart to get a definitive answer. So again, I subtract the 27x from both sides, and now I have greater than or equal to 0. Again, why is that important? Because on a sign chart, positivity versus negativity is revolved or dictated by the number 0. That's why it's so important. Before I go ahead and initiate my factoring, I will go ahead and ask myself, what is the final interval I'm looking for? Well, I want to look for where this parabola is above 0, so I'm looking for positive. So when I go to look at my final interval, I'll circle the positive ones. Okay, let's factor them. Should be pretty straightforward here. It's going to be minus, minus. I think a 5 here and a 2 here is going to be appropriate because that gets me 25 and it gets me 2, so that's 27. So I know I'm moving pretty fast, but I know you guys can keep up and you'll move fast as well with enough practice. 2/5 and 5 are my critical numbers here, so I'll go ahead and put those down here. 2/5 and 5. And I'm hoping you're starting to see the value of the shortcut here because it helps you just move pretty fast. So 5, I'm going to look at the x minus 5 here. 5 is the number that makes x minus 5 0, so he's an upward facing line, minus, minus, plus. 2/5 will make this guy 0, so minus, plus, plus. Plus, minus, plus are the numbers, or are the final signs. Greater than 0, positives is what I'm looking for, which means x has to be less than or equal to 2/5, or x has to be greater than or equal to 5. And that's what I'm looking for. So one of the things that makes this problem hard is that there are 4 things, but one of the things that makes the problem easy is that they're already factored, so we don't need to do any factoring or any kind of division or whatnot. So it's already set up for us. So what I'm going to do is I'm going to go and identify the critical numbers here. So the critical numbers are 1, 4, 1/2, and 1/3. Now, before I punch these guys into a sign chart, remember, I'm looking for where this big hunkin' thing here is less than 0. So at the end of the day, my final intervals will be negative. That's what I'm looking for. So I'm going to go ahead and draw one big hunkin' sign chart right here. Now there's a couple of things I want you guys to understand about this problem. Put a star next to the fractions, and put a star next to 4 minus x, because that's going to be where you're going to make your mistake. So let's go ahead and put the numbers in order. So 1/3, 1/2, 1, and 4. All right, so one big hunkin' sign chart here. I'm going to go and throw down x minus 1, 2x minus 1, 3x minus 1, and I'll throw down 4 minus x last. And again, I'm going to put a star next to him because something's going to happen with him that I don't know if you're going to be comfortable with. So using the shortcut, x minus 1 is 0 at 1, which means his signs will be minus, 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 plus, plus. Remember, anything before the 1 is negative, anything after the 1 is positive. So the reason why I put down these two functions here, the 2x minus 1 and the 3x minus 1, is because the 1/3 and the 1/2, they're really close together. Making a number selection, if you wanted to do it the slow way, really, really hard. Picking a number in between 1/3 and 1/2 is not fun. But as long as you know that 2x minus 1 is linear, and that 1/2 makes him 0, then anything before him is negative and anything after him is positive. Again, 2x minus 1 is an upward-facing line, just like x minus 1 is an upward-facing line. That's why they go negative before and positive after. 3x minus 1 becomes 0 at 1/3. He's an upward-facing line, just like 2x minus 1 is an upward-facing line, just like x minus 1 is an upward-facing line. Which means anything before the 1/3 will be negative, and anything after the 1/3 is positive. Now, if you're wondering why I was sounding like a broken record when I talked about upward-facing line, it's because 4 minus x is going to be a little bit different. I know what you're thinking. It's easy. He hits 4, minus, 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 plus. And I will tell you now to please remember that the problem is thinking against you. It knows what you know, which means it's going to trick you with this. The reason why I was such a broken record with these guys being upward-facing line is because 4 minus x is a downward-facing line. If you look at him, his slope is -1. because he hits his critical number at 4 and he's downward facing, it actually reverses the signs, which means anything before the 4 is plus and anything after the 4 is minus. So from here, how do we determine the final interval? So from here, negative times negative is positive, times another negative is a negative, times a positive will remain negative. Negative times negative is positive, times 2 positives is positive. A single negative will make this whole thing negative, all positive, and one negative will make him negative. And I'm hoping you guys are starting to realize the pattern with that. As long as there is an odd number of negatives, your final interval will be negative. If there's an even number of negatives, your final interval will be positive. Okay, cool. So how do I know which one to circle? Well, remember, we talked about that a few seconds ago. I want the negative ones because I'm looking for where my interval is below 0. My polynomial is below 0. So how do I write this in some type of notation? Well, what I can say is I can say that x is less than or equal to 1/3, or x looks like is in between 1/2 and 1, or x has to be greater than or equal to 4, and that is going to be your inequality. Okay, I think that's enough examples for one video. As always, please leave questions or comments in the comments area, and I will see you all in the next episode.